Again, this is Quai for Tech Lab channel. We are still on the same topic of first hop redundancy protocol. In this lab specifically, we will be configuring HSRP version 2. Of course, if you haven't watched version 1, you can always go back and watch it. So we have same lab that we have last time. So we have two routers, one switch, and then two client or end host devices. And we have that router which is sitting here. It's a visual router. It's not a physical router, it's a visual. And then we have this IP address which is 10.10.10.1. And if you look close, all of these IP addresses, they belong to the same network. Okay, our intention is to create some sort of redundancy here between the two routers. When this router goes down, this router over there will send a couple messages to find out if that router is still alive, and then this will assume the role of this active router. So this router, as a standby router, it will seamlessly act as an active router if that router is down. So its role is being a standby router, so that if that one goes down, this will just be an active router to forward the traffic to the visual IP, from visual IP to the internet. Okay, so we're just gonna start from scratch by assigning the IP address accordingly, and then we will differentiate between the two, version 1 and version 2, and how to configure version 1 and version 2. Alright, we're still gonna show how or the differences between the MAC addresses of version 1 and version 2. And if you watch the previous video, you will notice the difference between the MAC addresses of these HSRP versions. And then the multicast also is quite different. And then we still gonna be using the tracking to see if maybe this interface is down, and then this router will lower its priority value so that this will have a higher priority to act as an active router as soon as this one decrement its priority based on the tracking that is configured on this interface. When this interface goes down, this router will decrement its priority value so that this router that is a standby will act or assume the role of being an active router, because in HSRP the priority actually matters, right? So higher priority wins for the router to become an active router. Right, and then we're gonna talk about the timers, and then we're gonna talk about the authentication to prevent something called HSRP spoofing. Right, now let's get on to it and do some configuration on these interfaces. So let's select the router that we want to configure, and currently we need to enable the router by typing the command enable. From the privilege mode, we can show some IP interface brief to see if there is any IP address assigned. As you can see, currently we have unassigned IP addresses on this interface, and their status is actually down. So we need to change that by going to global config mode by typing command config terminal. From the global configuration, now we can start to assign the IP addresses. Let's start by assigning the IP address on that interface, gigabit 0/0. Right, so let's do that by selecting the interface itself, gigabit 0/0, and then from there, because we want to assign this interface, or we wanted to get an IP address from a DHCP server router that is sitting over there, let's type the command IP at DHCP, and then let's hook the interface by typing the command no shutdown and give it some time. The DHCP server will then give us the available IP address on its network range, okay, on its DHCP range. Alright, let's give it some time and wait and see. As you can see, we have a DHCP server address assigned on that interface, gigabit 0/0, and this is the IP address that we're given, 192.168.101.180. This is the subnet mask. Okay, if I can go back and type the command do show IP interface brief, I'll be able to see that now this status has changed to up, and then this is the IP address that we have on that interface. Now we need to configure this interface over there. These are our physical interfaces, and then when we configure HSRP, we need to assign this IP address on the visual router. Okay, on the visual router. Okay, so on that interface, because we would like that interface to participate on an HSRP, that's where we will have to create some sort of a standby IP and give it this IP address of 10.10.10.1. So now let's go to that gigabit Ethernet 0/1, and then let's do it. So let's select the interface gigabit 0/1, and then we want to assign the IP address statically in this time around. Because the IP address is already here, let's just use it 10.10.10.2, and let's specify the subnet mask 255.255.255.0. Alright, now because the interface is currently down, as we saw last time, the interface is currently down, so we need to type the command no shut down so that the interface will come up. Alright, let's give it some time. As you can see, we have the notification that tells us that this interface is actually now up. Let's run this command one more time. As you can see, we have up now, and this was done manually, statically. Alright, this is the DHCP server that leaves us with the IP address, but in this time around we did it manually. So we have 10.10.10.2 on that IP address. Okay, so let's move on to the other router and make sure that we do the same thing before we actually come to an HSRP. So let me just select the other router's interface. Okay, config terminal, let's create, or let's configure the host name R2. Okay, this is just to help us see which router we're currently on. So this is R2, and then let's select the interface that we want to configure. Same thing applies in here. We have two interfaces. We have gigabit 0 and gigabit 0 1. Right, so let's select the interface at DHCP no shuts down. Let's give it some time. The DHCP server will have to lease us with the IP address that is available on its range. Okay, and then we're gonna go down to that interface gigabit 0/1, and then we will have to manually or statically assign the IP address. As you can see now, we have this IP address that is given to us, 101.108. Let's move on to the other interface, which is gigabit 0/1. Assign the IP address statically by typing the command IP address and 10.10.10.3.255.255.255.0. Because the interface is down, let's type the command no shutdown and give it some time for the interface to come up. As you can see, the interface status is changed to up. Right, so if I can type the command do show IP interface brief, I'll be able to see that now we have both of the interface assigned with the IP addresses, but this one was assigned dynamically and this one is assigned manually. Alright, those are the two interfaces that we currently need for now, because we have those physical cables attached to them, as you can see. Now before we actually go to HSRP, let's try to include some sort of test if we can be able to go to the internet from both of these routers. Let's start by the router that we're currently on by typing the command do show IP, do ping 8.8.8.8. We're trying to ping to the internet to Google DNS. Let's see if we can be able to do that. Okay, all of those ICMP, the first one was dropped, but let's try one more time. As you can see, there is two difference that we can be able to actually go to the internet from that router. But to be sure that we really can be able to go to the internet from any physical source or from any of these interfaces, let's include the test. Let's say we want to go to the internet from that specific router itself, gigabit 0/1. Let's see if we can be able to go to the internet by typing the command source gigabit 0/1. This is the interface I want to test from. Well, we're not gonna be able to actually go to the internet. As you can see, all of the ICMP echo request, they are dropped, so we don't get any response. So let's try one more time to see exactly all of those, they are dropped. So I'm not gonna go back and check on the other router. Same thing applies on the other router. We just need to adjust our configuration to ensure that we can be able to ping to the internet. Alright, so to do that, let's start by doing some sort of let's just do some sort of dynamic routing. Let's use the OSPF, in this case OSPF 10, and then let's give it some ID. Let's say this is 2.2.2.2, and then let's just say network is 10.10.10.0, and the wildcard mask is actually 0.0.0.0.255. If you haven't watched how to configure OSPF, you can always go back and watch it. There are videos that are basically based on that. So let's exit, and then let's say do right. Okay, let's go to the other router as well, which is router 1, and see if we can be able to do the same configuration. Router OSPF 10, and then from our OSPF we just need to specify the router ID, which is 1.1.1.1, and then let's specify the network ID that we want to advertise on this. In this case, we want to advertise 10.10.0. This is the network ID, 10.10.10.10/24. So we need to include the wildcard mask, which is 0.0.0.255. If you don't know how this works, remember we have ACLs. It's only ACLs and the OSPF that usually utilize the wildcard mask. So if you don't know how to use, you can always go back and watch the videos that are based on the wildcard masks. Okay, so this is network 10.10.10.0. Okay, now let's save this configuration. Okay, as you can see, we have adjacency forming between these two routers. Let's give it some time. Alright, now let's go back to that router configuration and type in the command default information originate. We need to go back to the other router and do the same thing. Router OSPF 10 default information originate. Alright, now let's exit. Right, so now we have to configure something called ACLs. So we need to configure the access list, and then we can choose from these ranges. We can choose from 1 up to 99. This is the standard access list, and then from 100, this is an extended. The list goes on and on and on and on. In future, we'll also touch upon time-based. So for now, we just want to use access list 1, and then on an access list, you can either deny traffic or you can permit the traffics. So what we're trying to do here, we want to permit anything, so which means we want to permit any host or any IP address or any network. So we need to specify the command IP permit any to do that. All right, remember there is an explicitly deny in the end of an access list. So let's come in here. Let's go and do the same thing on the other router as well. So let's come in here and type in access list, and then this must match. We using the same access list 1, and let's say permit any. Okay, let's save these configurations. Okay, so before we actually go to HSRP version 2, I just want us to touch upon this configuration to ensure that we can just ping from that interface or from gigabit 0/1 to the internet. Okay, so let's run a ping and see if we can be able to ping from that specific source. Well, it looks like we cannot, but let's see if we can. We're just gonna run it again on this side. Let's give it some time. I'm just gonna run it twice so that we ensure that it's not just because of that first packet dropped or the app. So as you can see, we cannot be able to, because we need to further configure something called network address translation or port address translation. Alright, so we just want to overload the interface, one of the interfaces, which is gigabit 0/0. We just want to overload it, and then we want to make that interface to be an IP net outside, and then the interfaces that are inside, we want to associate that gigabit 0/1 as the IP net inside. Alright, let's do that right now on both of these routers. Let's start from this side and type in the command IP net inside, and then let's say source list. We're just gonna use the access list that we created, access list 1, and we want to select the interface, and then we just want to use gigabit 0/0, and we want to overload it. Okay, I'm just gonna do the same configuration here once and for all. So we just need to type the command ipnet inside, and let's use the source list 1, and then let's select the interface gigabit 0/0, and let's overload that interface. Okay, now all we have to do, I'm just gonna do the same thing on here. All we have to do, we actually need to specify that the interface, which is gigabit 0/0, we want to be up IP net outside. Okay, let's leave the router as it is for now. Let's select the other interface as well, gigabit 0/0 IP net outside. Okay, we're just gonna give both of those routers to refresh, and then once this is done, and then we're gonna carry on, and then we're gonna be able to further allow gigabit 0/1 as part of the IP net inside. Okay, let's give it some time. I'm just gonna pause the video once this is done. Okay, here we are. Let's see if we can carry on. Yep. So now I need to select the interface gigabit 0/1, and then IP net inside, do right. Let's wait for the configuration to save, and then let's do the same thing on this router over there. Interface gigabit 0/1 IP net inside. Do right. Okay. Exit. Do ping 8.8.8.8 from a specific source gigabit 0/1. As you can see, the difference now is we can be able to ping after that we have allowed the traffic from inside to go outside via the access list. Alright, so we can ping to the internet, we can also ping to Cloudflare DNS. Okay, we can ping Facebook, we can ping everything from there. Now let's verify on this side too. Do ping 8.8.8 from a specific source of gigabit 0/1. As you can see, we successfully send those ICMP echo request, and then we got the replies 5 out of 5. Okay, now that we are here, let's go back to what we are here for today, which is HSRP version 2. Okay, remember what we said about this. This is a failover mechanism, or it's a redundancy solution where we have multiple routers, or in this case we have 2 routers. Well, we want to elect one of the routers as our active router that will be responsible for forwarding traffic. But if it happens by any chance that the interface or the router itself goes down, the router which acts as a backup will assume the role of an active route by after sending the COP messages. Alright, that is the multicast traffic that is sent by the standby router, and then it assumes the role of an active router. If the router that was active is down, and then the standby router will simultaneously or seamlessly change its state from being a standby router and then become an active router to forward the traffic. Alright, the client computers that are here, they really don't have to know anything about these physical interfaces. On their network interface card, they only are aware about one IP address, which is very important for this. This is the visual IP address. So these client computers, they will only have the default gateway of the visual IP or of the visual router. Alright, so which means the visual router is aware about these interfaces, but the clients, they are not aware. Alright, so if that interface goes down, this router will become an active router and communicate with the visual IP to keep the internet flowing. Alright, so that these computers will be able to communicate with the internet without any failure. Alright, or without any packet being dropped. So now on version 2, let's see how do we normally configure it. On version 1, if you remember, or if you don't, you can always go back and watch. When we were configuring version 1, we didn't specify the version number. We just dived in and selected the interface and then typed the command standby, and then we selected the group, and then we assigned the IP address of the visual router, and then that was it. But in this case, we will have to specify that now we are configuring version 2. How do we do that? We select the interface that we want it to participate as HSRP by typing the command gigabit 0/1. These are the interfaces that we want them to participate on HSRP group. So by typing the command standby and then specify the version, which is version 2, I'm allowing this router to, or that interface specifically, to know that now this is the version 2 that we're dealing with. So I can fairly say standby and select the group, what you will notice from here, the group range is also different. So I'm just gonna put this so that you will see this time around it starts from 0 up to 4095. It's unlike on version 1 where it starts from 0 up to 24. Obviously you can see the group range from here. This is the group numbers that we can select from. Okay, so let's come in here and select the group that we want to use. In this case I'll use 1, and then I want to assign the visual IP address, which is 10.10.10.10.1. I don't need to specify that subnet mask because it is expected that it must be within the subnet. So let's give it some time. As you will see that the status of this router will change to be an active router. But while we're waiting, let's configure something else, which is called the priority. The priority, as you can see, this is active. As I have said, that we can give it some time. Okay, this is an active router now, but to ensure that this remain an active router even when we configure the other router, which is an HSRP version 2, we need to configure something called priority. By default, the priority value of an HSRP is actually 100. So in order for us to ensure that this router remain an active router, we need to higher its value up to maybe 101 upwards, just a greater value than 100. In this case, I'm just gonna say standby, select the group, and we need to say the priority is actually gonna be, I'm just gonna make it very higher, so I'm just gonna use 150 in this case. Alright, and I want this router to actually become an active router as long as it's on. So there is a command that is called preemption. So we need to type in preempt to enable that concept. So basically we want this router, even if this standby router assume the role of the active router if this interface is down, but as soon as that interface comes up, we would like to prefer that router to always be a forwarding router or an active router. Okay, yeah, so by typing this command preemption, that's what we're telling the router, okay, to do, to always claim its role as long as it's on. So now let's come in to verify our configuration by typing the command do show standby. Alright, do show standby. So the router in here, it actually a standby router. Right, so now let's run this again. I want us to run it again so that we will see. If I shut down this interface, which is gigabit 0/1, let's select the interface first, select interface gig, and then let's shut it down. Instantly after I shut it down, remember we get that state because that router send the multicast group messages, and then this router send the resign messages that's about to go down, and then this router took over the role of being an active router. Okay, right, so this router is an active router. Now let me hook up the interface again and re-explain this. Because now the interface is up, it will take its role back by force because of that preemption configured on the interface. And the OSPF will also form the adjacency or the membership between two routers that are running the OSPF. Alright, now let's go back to these clients. I'm just gonna select this one and assign the IP address because the other one is assigned. So I'll type in the command show IP on this client, and then to assign the IP address I must type in the command IP and then specify the IP address that I want to configure. In this case I will use 10.10.3 with /24, and then I want the default gateway to be 10.10.10.1. Okay, it says that checking for a duplicate address 10.10.3 is being used by MAC address blah blah blah. Alright, let's leave that one and go back to this one over here and see which one is running. The reason why is because I was giving it the wrong IP address. I should have gave it 4. That this is the interface that is actually they're talking about, this one. Okay, this one is taking some time. Let's just go back to the other one. Okay, I'm just gonna assign it again. IP 10.10.10.4. This is the IP address of this host, and then I'll just specify this is 24, and then let's specify the default gateway of 1. Alright, it's checking for the duplication of IP address on an entire network. It didn't find any, and then here we go. We have that IP address assigned onto that client. Okay, let's configure the DNS on this IP DNS 8.8.8.8.8. Show IP information, and then as you can see we have the host IP of .4. We have that gateway of visual IP address of the default router or for that visual router. Right, what can we do with this information? We can try to ping to that visual IP to ensure that we can bridge it. As you can see, we can actually send those ICMP. See, this is the first sequence, this is the 5th sequence. Okay, right, so we can ping. We can also ping these interfaces, which is 2, and we have that one which is 3. Right, we can successfully ping all of them, but the reason why we have set this to be the default gateway, we don't want that when this router or when this interface goes down, we need to go back to these clients and change now the default gateway of these clients and point it to this one, 2.3. We don't want, rather we want to use the visual IP, because the visual IP will know which interface is down, and then this interface will then communicate with the visual IP to send the traffic to the internet. Okay, or send it down to the local area network. Alright, so now after verifying that, let's run some tests. I'm just going to run the trace again. I want to see the way towards that visual IP. Okay, this goes via .2, but let's go and shut down .2 and see which way will it go. I'm just gonna shut down this interface so that this router will become an active router. As you can see, this router now is an active router, and I'll just go to that client PC and run the same command. You will notice that now it was trying to reach 2.3 because .2 is down. But let me go back to this interface and hook it up. Because of preemption, remember, this will take its role back to an active router. And of course, if I go back here and trace, you will notice it will go back to, it will try to reach 2.2. Alright, now we have actually successfully configured this HSRP, and we have tested how the failover actually works. Now all we have to do is to do the tracking, right? But to do the tracking first, let me go to this interface, which is interface gigabit 0/1, and then I would like to enable something called preemption. Okay, now let's come out and introduce something called tracking. Okay, what is tracking? Remember, we been assigning these interfaces part of the HSRP group, but we didn't touch these interfaces. So which means these interfaces, they can communicate to that visual IP, but what about that visual IP? I mean, what about that interface if it goes down? So let's say this interface is actually up, and that interface, yes, is very up, but these interfaces, they are down, or one of those interfaces, they are down. So which means the packet on that interface will be dropped. Alright, the packet will be sent from this client, and then it will go and take the correct route based on the visual router or based on that physical interface. But from here it will be dropped because we won't be able to ping to that. Alright, so what do we do then? So we will have to configure something called tracking to tell the other router that as soon as this interface is changing its line protocol, then we want to decrement the value of what? Of the priority configured on this HSRP to be actually lower than the priority of the priority configured on the standby router, right? But to do that first, we will need to go through the global config mode on the router to create tracking object. So let's come in here and see if we can do some sort of track and then specify the object number. Okay, so as you can see, we are actually tracking the interface. So we want to track the interface. You can track the application, you can track the IP addresses, but I want to specifically track the interface. I will type in the command interface, and then I will specify the line protocol. Okay, let's see if it's gonna allow us. I need to specify the interface that I want to track. In this case, I think that is the interface that we're willing to track, and then line protocol. Okay, I will do the same configuration on this side by typing the command track one interface and select the interface that we're willing to track. In this case, this is the interface that we're willing to track, and we're willing to track the line protocol. Okay, so as soon as it's down, the value of, we want the value to decrement. Alright, so now what do we do? From here, we need to tell the interface that we want to decrement the value from and make it aware about that tracking that we're running on that interface. So which means I need to go back to gigabit 0/1, and then I'll still have to type in that command standby 1 track 1 decrement value by. I want to decrement the value by, as we know that on this router, which acts as an active router, currently it have the value or the priority value of 150, and on the backup router on this side, we know that it is actually do shows running it running 100, priority of 100, but let's verify that do show standby. As you can see, it have the value of the default, which is 100, default priority, which is 100. So we want this active route, if as soon as that interface changes its status, we want this to stop being for a forwarding or a an active router. We want this to be an active router. So by doing that, we want to lower the priority automatically. When the interface goes down, we want to lower the priority of this one automatically to less than 100. So we can minus, or we can subtract 150, or we can subtract actually we can subtract 60. Right, so if we subtract 60, or let's say 60 from 150, that will leave us with 90, right? So 90 will fall below then 100, which will make this standby router to assume the role of being an active router. So we want to decrement by 60. Okay, so let's do that right now. Okay, we have actually configured the tracking on that interface. Now let's see what happens if we shut it down. Now we're gonna shut down that interface alone and leave this interface running and see what's gonna happen after that. So let me verify this. Do show standby first. As you can see, we have that tracking object now running, which will actually decrement the value by 60 as long as that interface change the protocol, the line protocol. Now let's do that. Let's select the interface gigabit 0/0 and shut it down. Let's see the status, or let's see how HSRP then will uh, decide who will become an active router and who will become a standby router. As you can see, as soon as we shut it down, that interface, this router has become an active router, and this router itself, it became a standby router, right? So this is how tracking works. This router now is an active router due to that this interface has changed state. That interface has changed state to be shut down. This interface is now not active, it's inactive, and because of that we don't want that. So we will decide that this router will have to lower its it will lower its priority to a lower priority than the priority that the standby has, which was 100. And now on, if we check here, do show standby. If we check here, we have actually have 90. We have 90 priority, which is less than 100. It makes this router as the active router because we have this tracking object running. It says we want to decrement the value by 60 as long as you find that interface being down. Alright, now let's see what will happen if we hook that interface back up. Let's select the interface gigabit 0/0, no shuts down. Okay, let's see what's gonna happen. As you can see, instantly after we have hooked that interface up, and this was linked with an IP address back by the DHCP server on the other side, and the role has been given again of being an active router. Do show standby. As you can see, we now have the priority to 150, right? Because the interface is up, therefore we want this router to remain an active router for the traffic. Okay, so this is how tracking actually works. Now let's go to authentication. Okay, so on authentication, what we're trying to achieve here, we trying to ensure that we avoid some sort of HSRP spoofing. So if you know what spoofing it is, let's come in here. So to do that, we need to select the interface again because we need to run it on an interface gigabit 0/1, and from here we need to actually select the standby one, and from here we're gonna be using this authentication. There are two authentication types that we can use, keychain and string. So let's use, okay, let's come in here and specify authentication first, and then I'm just gonna show you. We can either use a message digest, which is MD5, or we can use a plain text. Alright, so let's come in here. So we need to specify that we want to use MD5. From here, let's further check which one we're gonna be using. We're just gonna use a simple string. We're not gonna use the keychain. So let's just use key string, and then what is our secret, or what is our password? Let's just say Wi-Fi tech, Wi-Fi tech. All right, and then press enter. As soon as I've enabled the authentication, it will tell us that this other device on the other end, it fails to authenticate because the other, okay, let's come in here to ensure the other router on the other end have not yet configured with authentication. So this router will not be an active router until that router configure the authentication on the other side. So now let's do the same thing by selecting the interface. As you can see, bad authentication. Let's come in here, interface gigabit 0/1, and then from here we want to configure the authentication by selecting the standby group that we want to configure the authentication from. Authentication message digest 5, this is MD5 authentication type, and then we want to select the, okay, we want to select the key string to be Wi-Fi tech. Alright, now let's give it some time. You will see that the first router will try to be an active router once again because it will detect the other router to act as a standby router. Okay, let's give it some time. As you can see, this router is a standby router now because this router is actually do show standby. This router now is actually an active router. So I hope this video was so informative to you. On an upcoming videos we will move to something called VRRP, okay, where we will actually have some group of routers, and we will have something called master within them, and the master will be the one that will be forwarding the traffic. So the other routers will remain as standby routers, while one of the elected routers master will actually be the one to forward traffic. Alright, and we will, after that, we'll move to something called gateway load balancing, a protocol, and then after that we will have to configure some sort of load sharing between routers, that the other one run both active. One router will run both active and backup, and the other one will run both backup and an active router. Alright, so I hope this was so informative to you. Let's meet again on an upcoming video.